goes to the drilling location. It pins down, means once it reaches the location, the legs are lowered. Once legs are lower, and it is called a soft pin once it starts touching the water bed. So once pin down is done, the preloading operation takes place. This is a very important operation because preloading makes sure that your leg and the spud can is firmly sitting on the water bed, so that during operation there won't be any further movement of the vessel or the leg. So spud can is the main part for it. So basically spud can, I will go through in the further side with the each and every line item what is the function of it. So now on the jackup rig, the main person on board, the main control person having his OIM, is the offshore installation manager. So is the main person, we can call it lead member, lead person on the rig, who is controlling everything on board. And there will be a client representative, which is called as a company man. Suppose if a rig is operating for Saudi Aramco, for Aramco field, there will be an Aramco representative on board and OIM from the rig itself. Then the second person is tool pusher. He is the one man in charge for the drilling operation. So under him there will be driller, assistant driller. The next person is barge master. Barge master mainly is the head of marine department. Like all the preloading operation will be taken care by barge master. Which tanks are to be loaded, what will be the loading sequence, how much quantity preload is required, and all the jobs related to the barge itself will be with the barge master, along with the lifeboat, rescue boats, davits, all those things will be with him. Chief mechanic, he will take care of all the equipment and machineries on board. Chief electrician, all the electrical parts, and camp boss, he's the in charge for the accommodation and the galley areas. So now leg. The leg is the important component of the jackup rig. Since once it reaches the jackup drilling location, the jacking system lower downs the leg. For that, for this to happen, every leg will be having most of the legs are either circular, which we call it as a tubular section, or rectangular or a square hollow section. Some the another type are lattice legs, which are again square or triangular. Most of the rigs are with this lattice structure with a triangle. Every leg section, this is called cord, will be having a rack connected to it. The tooth section, this is called a cord. Ahmed, you can see my pointer.
Yes, Rajat.
This is a cord. So this is the part which connects with the jacking system. This is like a rack and pinion arrangement. I will go to the next slide afterwards. So this cord teeth engaged with the jacking gear teeth and the jacking operation takes place. The most of the lake constructions are K type. Now most of the recent lakes will be having this structure only. Before it used to be a Z type structure. So this is what the recent constructions are, most of the lake. So now these horizontal members are called bay. The leg is measured in bays. So this is like this is bay 1, then bay 2, bay 3. So the first bay above the spud can is called bay 0. We will come to that slide afterwards. Okay, here. Now spud can. Why we need spud can for the legs? Because spud cans are like inverted cones which are connected to the leg structure and which is having the node areas. Some spud cans are dry, some are wet. Means we have to fill these spud cans before we deploy them for operation. It depends on the location where they are and what's the weight of the what you call Jacob rig where she is operating. So this shape of the spud can gives the inverted spud can, it gives the leg firm sitting on the water bed. Now these spud cans are provided with jetting lines, some on the top and some are in the bottom. There are two types of jetting lines. One is low pressure and one is high pressure. The low pressure lines are operating at 10 to 15 bars and high pressure 50 to 60 bars. These are sometimes mostly connected with the mud pump. One diversion is taken from the mud pump and filled. Why we need these jetting lines? See, whenever we are lowering the leg, so these jetting lines, they will clear the loose mud from the location, and the spud can rest easily and get a firm landing on the water bed. The second importance of jetting line is when you retract the leg, this area will create a vacuum. Suppose in case if we don't have jetting lines, then if this vacuum in this particular areas will give lot of load on the jacking system. So what jetting lines does it will blow the water here, and this will reduce the vacuum in this area so that the leg can be retracted easily from the water bed whenever movement of the leg is required. So is this part clear? Ahmed?
Yes,
Any
yes.
question? Yeah. Let us. Any question, ladies and gentlemen?
It's clear.
Okay, I will
Yes,
go to the
Dr.
next
Tena.
slide. Okay, now jacking system. On the leg, I was showing the cord. So this is the cord having the same teeth arrangement like as a pinion. So jacking gears, every leg will be having a jacking system. Then there will be a number of pinions connected on each cord. So for example, this leg is a triangle one. So this is cord A, cord B, cord C. So there is numbering alphabetical order given for these cords. Then cord D, E, F. So this is numbering given for them. So each cord will be having each area will be having a cord teeth rack which will engage with the pinion. So every location, every cord area will be having a jacking gear pinions which will move this leg up and down. There are two types of jacking system. One is electrical operated and hydraulic operated. For electrical ones, we'll be having the motors which will be fed from the main switchboard. In hydraulic system, hydraulic motors, hydraulic cylinders, which will be operated again with from the main switchboard to electrical power and then to the hydraulic power pack. Okay, this is the jacking system now. So normally what we have in ASRE is we get most of the rigs from Saudi Aramco. And Saudi Aramco is having their own standard. They call it a Schedule G. So they follow same like IX. It's a universal standard. But for Aramco, it's a Schedule G standard, which each and every rig operating in Saudi Aramco field have to comply with. So most of the rigs which are operating in Saudi Aramco are operating at a water depth of 350 feet. So the minimum leg length required is 492 feet. So each and every rig should comply with this requirement of the Saudi Aramco. And also the cantilever extension should be around 60 feet. And the drill floor cantilever will be moving only longitudinal direction. Drill floor should have a transverse movement. So transverse movement is 15 feet on each side. These are some of the requirements for Saudi Aramco. So now we will come to cantilever and skidding system. So now, why cantilever is required for us? Suppose once the rig is stationed at one area, okay, it does the drilling in that particular area, and the well is secured. So now suppose if we want to drill another well only around 15 feet away from that. So what we'll do, we will reposition the rig again? No. So cantilever comes in picture after that. So what cantilever does, cantilever moves herself out to the desired location. No need to shift the barge, the vessel, the barge itself. So and then it can center itself and do the drilling operation. So for this cantilever to move, we are having again two types. One is hydraulic.
Rajnath, your sound is cutting.
Yeah, Ahmad, because actually I'm in office and okay, now looks like I've got the connection. Just a moment, just a moment. Because I was on my mobile hotspot. Just a moment.
Take your time.
Okay, Ahmad, yeah. So these are of two types, same electrical motor operated or hydraulic. For hydraulic, now these are called hold down points for a cantilever. Since cantilever is a movable item, so it cannot be welded down directly to the main deck here. So these are the hold down points, and there will be a skid rail. These are called skid rails for the cantilever. That's why it is called cantilever skid rails, and these are hold down points which you are having holding down the skid rail in location, and some are guide cells which will guide the cantilever. So for hydraulic ones, it will be having on the side here, there will be a structure, a thick plate having holes. So that the hydraulic cylinder can move and connect to the hole, and then the cylinder can retract. So giving it, okay, skidding out the cantilever. Normally the hydraulic skid out is a slightly slower process compared to the electrical one. So electrical one with the tooth pinion and rack and pinion, it's a continuous process. So for hydraulic, we have to wait for every stroke to retract and again connect back. Now this is a barge. The main layout is all the side areas will be having preloading tanks, which are required for the better good lake penetration into the seabed. These tanks, center tanks, most of them will be having drill water. So this is the one which is required for mud pits, mud mixing, and for the drilling operation. Some fuel tanks and freshwater tanks. Now moving on to helideck. Saudi Aramco comply with, or any rig going to Saudi Aramco should comply with CAP 437 requirement. This is for civil aviation publication, civil air publication. So civil aviation authorities, they every time they come up with different sets of rules. So it looks like now they are at revision number 8. So this is what presently every rig have to comply with. So they'll be having CNH lighting. These are the H lighting required. Then the perimeter lightings, tie down points. Depending on the size of the helideck, the tie down points will be identified, and a chevron angle. Chevron angle, this is the one towards the aft end of the helideck. So this indicates that this is beyond this point. So once we extend this line, so anything coming within this can be obstruction point. Beyond this line, we shouldn't have any obstruction for the helideck, nothing. And the thing is, on the top of the pancake, suppose there are a lot of platforms which will be coming on the side for firefighting, stairways which to go underneath the platform. So these areas, nothing can protrude more than 200 mm above the pancake level. So this is their requirement. And the helideck should have a DIF system, deck integrated firefighting system. This is the requirement for Aramco nowadays. So this is same like what we have water mist system in the vessels. So same type of system this is. Now coming to the heart, this is the heart of a rig. So in this picture, we will see only the main components, then we'll go one by one through them. This is crown block. We can call it a winch for any crane, for example. These are the lines. You can call it a hoisting line. Now for this winch, there will be a drawworks and the drill line will be passing from here, and which will be holding the traveling block and top drive. So we'll come to there. Number 3, drill line, monkey board. So this is the area having a platform. So here we'll be having the stabbing board. What happens is in this area. Okay, I will tell the drilling process first. Now the drill pipes are stored on cantilever deck of the rig. Okay, it will be some of the pipes will be stored on the cantilever deck and some below the cantilever on the main deck. So what will happen is when the drill pipe will be transported from the cantilever deck, the rig crane will be taking this drill pipes to this V door. This is called V door. This taper shape is very important so that this will allow for the easy movement of the drill pipe. So these drill pipes will be laid down on this V door, and we'll be having a lot of winches here. There are plenty of winches, 5 ton, 10 ton, 3 ton, 2 ton in this area. So these winches will bring this drill pipe, and we'll be having a fingerboard here. So this fingerboard will be vertically stacking this drill pipe. So each time we don't have to bring a single pipe and put in the rotary table here. So we have to stack them. Every rig they'll be having a very limited time to get the drill pipes connected and do the drilling operation. So here monkey board area will be having a fingerboard wherein all these pipes are stacked, most of them. And then one by one, once one pipe goes down, the pipe will be lifted and brought here. So that's why we have working platform here with winches for holding the drilling pipes. Number 5 is a traveling block. We can say it's like a floating block of a crane. And then top drive. Top drive is the main part who holds the drill bit and gives the rotation movement. Mast, we can call it a derrick. Dockhouse. Dockhouse, we can call it also, it is called as driller's cabin. This is from where the driller, tool pusher and driller will operate the top drive and all these equipments. Blowout preventer. This is a safety well control measurement, well control system. We will come to that. And water tank for all VFD and whatever cooling requirement required for the equipments here, because there will be frequency converters also in the switchboard for the drill floor equipments. Generator, fuel tank, engine control, mud pumps. We'll go to mud pumps. We'll go to the mud pump cycle separately. Mud pit tanks. This is just a view shown, but on the rig it will be like a separate compartment. Reso pit, sludge pit, mud gas separator. This is one of the well control items. Shell checker. This is required for the mud cleaning, return mud cleaning. Choke manifold. These are well control item equipment. We'll go to it. Pipe ramp, also called as V-door. Pipe racks to hold or keep the drill bits. Accumulator, which will give the required hydraulic, which will operate the Kumi unit or blowout preventer. Going briefly, crown block, derrick, traveling block connected with the swivel where the Kelly hoses are connected. Rotary table, which will be giving the rotary motion to the drill bit. Blowout preventer, if there is a kick or a back pressure, high back pressure in the safety requirement, we'll come to this later. And this, okay, now I will go to the mud circulation system. How does the mud system flows here? For any drilling operation, we'll be having mud pits. The mud pump will take the suction from the mud pits. Okay, why mud is required for the drilling operation? While we are carrying out the drilling operation for the well, there will be drill bits here. So any drilling operation will produce heat. So mud is like a lubricant for the bit. This is one first function. Second function for the high pressure mud delivered to the drill bit will be to move the cuttings away from the drilling area. So this high pressure mud will make the cutting of the hard rock or from the well itself to move away, so that this will give way for the drill bit to go to the new areas. So the mud pump, usually the mud pump will be delivering, this is the low pressure suction area, delivering the fluid to around 5000 psi or 7500 psi to the drill floor. So here, since cantilever is moving, so we'll be having a hard piping running from the machinery space mud pump up to the main deck. Mud pump will be somewhere here inside the machinery space. So this piping will be running and coming up to somewhere on the aft area of the main deck. So if we make the hard piping again, this cantilever cannot move. So it will be having hoses, which is connected to the drill floor here. And from there again, we'll be having one manifold on the drill floor, which is called as a standpipe manifold. And our Kelly hose will go further. So hard piping in machinery space up to the deck, and then flexible, then the hoses. Okay, this line, let's consider this as a hose area. When it comes to the drill floor, we'll be having a standpipe manifold. And standpipe manifold will be having two lines. Suppose if it's like one line will be a backup and the second line will be in operation. Suppose in case if we have any maintenance, then the manifold here, standpipe manifold, will keep one line in operation, and other we can maintain. Once after that, we'll be having this Kelly hose, which will be, and this is a swivel. This is the main function of swivel is to connect the Kelly hose. Okay, and so that, and this swivel will be having a rotational motion only in this area, lower area. So this upper area will be stationary. It won't be rotating. So that means since the swivel, the top drive will be connected here, and it will be having the drill bit will be having rotary motion. So top area stationary and lower will be a rotary motion. So this mud will be going to the drill bit. Drill bit will be having an external chamber also, from where internal chamber the high pressure mud will go, move away the cuttings, and the outer area of the drill bit through the BOP, blowout preventer, the return mud will come. So this return mud will be carrying with her the cuttings and other impurities from the well. So now this mud, we cannot discard all of them. So this mud will be going through the filtration process, cleaning process. So for that, we'll be having shell shaker, mud cleaner, descender, desilter. I will come to that in the how it looks. I will show in the further slides. So this process, like a shell shaker, will remove the major cuttings from the mud. Mud cleaner is the next step of filtration. Then descender, it will remove from 45 to 74 microns. Then desilter will remove from 15 to 46. So this the filtered mud will go return back to the mud pits. So then in the mud pits will be having different types of mud prepared by the mud engineer. So that is totally a different complex scenario. So mud engineer, they'll be having ecological and all other things. They'll be getting the sample of that particular area, where mud sample of the particular area where the rig is going to drill, and what depth is the well, what kind of depth of drilling is required, what is there underneath. So when they do the subsea survey, based on that, he will prepare the required mud proportion for the well, for the mud system. So there will be some reserve tanks and some active tanks for the mud pits. So this is how the mud cycle operates. So now going through the components, drawbacks, we can call it. Yes, Ahmad?
Can we just stop a minute to start getting questions if there is any? So, ladies and gentlemen, any question from your side? Let us start. Mahmoud Mohsen.
Yes, Usman.
Yes. Yes. Any clarification you have?
No. Everything is okay. Thanks, Rajat.
Khaled Abdelghani.
يا باشمهندس
Any questions you have?
كله تمام واضح يعني.
Okay. Mahmoud Hassan. علاء سعيد. علاء سعيد. احمد طارق. طيب
مع حضرتك يا باشمهندس.
any questions Ahmad you have?
No, it's clear يا باشمهندس.
It's clear for you the mud system? If you have any questions, you can share it with us. Ahmed,
ايوه حضرتك يا باشمهندس.
well, like if you have any questions, you can share it with us.
Any question? I will share it.
Okay, Rajat. Okay, Rajat, you can continue. Okay, Rajat, please. Rajat, you are mute, I believe.
This, Ahmed, can you hear me?
Yes, Rajat, now. Okay.
Yes.
Yes, Rajat, I can hear you. Yes.
Yeah. Okay. So this is Drawworks. This is how a Drawworks looks. This Drawworks is basically a winch, a high capacity winch, which will be feeding the one crown block on the top, which will be having a number of sheaves, which will go through, which will passing the drill line to the traveling block and the top drive. So we need this arrangement so that the top drive can be lowered, raised and lowered with the drill bits. Now traveling block. What is the function of traveling block? Traveling block is like same, is like a
Rajat, your sound is
floating
cutting, Rajat.
block.
Rajat, your sound is cutting.
Ahmed, yeah. Is it clear now?
Yes. Yeah, can you go?
Yeah.
Can you go back one more slide and start?
Yeah.
Yes.
This is how a Drawworks looks. Drawworks is basically we can call it a winch, a big winch, which will where the drill line will be spooled. So this drill line will be passing through the crown block with the number of sheaves, and which again
Rajat, you have a network issue. Your sound is cutting.
to my, yeah, because I'm getting call from 1 second. Spare me some time. I will connect.
Oh.
Hello. I'm good, Mr. Omar. Khalas, huh?
Okay.
Hello. Yes, Ahmed. Ahmed, can you hear me now?
Yes.
Yes, Rajat.
Okay, sorry for the interruption because I was on my mobile and a lot of calls were coming, so the net was getting disconnected.
No problem, Rajat. Actually, I am the one sorry because you have undocking tomorrow and I'm squeezing you here.
Okay, we are on the traveling block. We can call it as the same. On the crane, we have a hook, the floating block. This is the one we can call it, but this is a high capacity one. So this traveling block is required to hold the swivel and the top drive. The swivel will be having this Kelly hoses, and the top drive is the main who will be rotating the drill bit for the drilling operation. So this is the crown block on top of the derrick. Above this crown block, sometimes we'll be having, normally they call it as a water table on top. Here there will be some of the rigs will be having a beam structure on top to carry out some maintenance on the crown itself. So the drill lines pulled from the drawworks will be coming here, going through.
Rajat, back your
The
sound
sheep-
cutting.
Mr. Ahmed,
Yes.
the sound for me is good.
Ahmed, can you hear me?
It's cutting from your end, Ahmed.
From my end? Okay.
Ahmed, shall I continue?
Yes, you can, Mr. Rajat.
Yeah, okay. The crown is having a number of sheaves, so we can make it like multiple strands. So number of strand increases, it will give more capacity to the wire rope for any lifting purpose. So this is how where the crown sits on the topmost part of the derrick, and this is the water table area, what we call. Then we'll go to the hook. The traveling block will be having a rotating hook, wherein the Kelly hose, and these are called bells. We can call it, in other words, arms also, like our hands, which are used to connect to hold some of the drilling equipments like this bushing, Kelly bushing, or tongs. So we'll come to that afterwards. So these are like hands, arms. So this swivel is having the connections for connecting the Kelly hoses. So this hook will hold swivel and the tong bells and some other drilling items required for the driller. Drilling line from the wire rope, which is same like on the crane, the wire rope what we have, this is called a drill line. Elevators are like clamps. See, these are our hands, which I was saying, bells. So this will be holding elevators or some other stuff which are required to handle the drill pipes or any bushing or any other drilling equipment. So this will be used. So elevators are like clamps to hold a drill pipe. Now rotary table. So there are now for the drill pipe to give rotary motion, there are two scenarios. One is rotary table. Before we were having the rotary motion was given by only rotary table, which will be having a drive shaft going horizontal, and it will transfer this motion by 90 degrees. So the rotary will be moving. So this will give the required rotary motion to the drill bit. So how this is done? So rotary table will be having a master bushing connected here. This for small rigs, this is single unit master bushing. For bigger size, it will be in 4 or 2 parts, so that they can handle this easily. So this master bushing will be having another bushing going inside. Okay, and after that we'll be having in the Kelly bushing will be having a Kelly like this, like connectors, what we call to connect the drill pipe on the top and connect the bottom one. So once we have this drill pipe, we'll be having clips. I believe I don't have them here. Okay. So rotary table will give the rotary motion to the drill bit, which is connected to the top drive in some cases. Okay, now recent top drives are designed in such a way that this top drives itself gives the required rotary motion for the drill bit to do the drilling operation. So these are the Kellys. So this goes in the rotary table. This is like a locking arrangement, and then the drill bit is connected on top here, and then the required rotation motion is given to the drill bit. These are the master bushing, which are on the rotary table, and this is Kelly bushing. Kelly bushing is the one which holds the Kelly. Top drive, as you said, top drive is the one who gives the rotary motion to the drill bit. Swivel, as I said before, swivel is the main part which is holding the Kelly hose with a rotary motion in the lower area, and the top portion is fixed. Kelly hose, these are the one. So we'll be having a standpipe manifold on the drill floor, and from this, after that will be a flexible hose going up to the swivel. Now mud pump are the reciprocating. Most of the mud pumps are reciprocating. So they will take the low pressure mud from the mud pits and deliver them at 5,000 or 7,500 psi as per the requirement of the rig or the field. So these ball type structures here, these are called pulsation dampeners. See, every reciprocating motion will be having like a jerky motion for the fluid. So every stroke, this can be a double acting, a single acting or double acting. So what this dampener does is they will remove this jerking motion. So this will reduce the jerk in the fluid. Now this were the things I was talking about, the mud return. For mud return, we'll be having the shell shakers. First step will be shell shaker, the return mud from the well. Okay, the return mud from the BOP unit will be, and from the return line will go to the shell shaker. Shell shakers will be having like screens on top. These are like shaking screens, which will remove the bigger size particles. Mainly, we can call it the cuttings from the well. So what they do is the clean mud means the required mud will be falling from the down area into the mud flow line, and there are, like we can call it there are some tanks on the rigs below. It will be going to that, and the cuttings from the screen will be going to the overboard ditch. There will be an overboard ditch, so all cuttings will be going directly to the sea. So now from the first stage, whatever good mud is there, it will be going to the descender. So these are having like hydrocyclones, like a centrifugal force, and this will remove the particles which are around 40 to 60, 45 to 70 microns. So all this will be going again to the ditch and then out. So from the descender, the mud will go to the desilter. Again, further filtration will be done, and from there it will go to the mud flow line, through the mud flow line, and through the desilter, descender pumps, and then back to the mud pits. So this will go to the reservoir pit, and from there, all the mud pits will be having equalizing valves. So whenever from any of the pit they need the mud to go in the slush pit or the main mud pits, they will be transferring through the equalizing valves. So this picture is showing only the actually land rig. On the rigs, it will be like compartments, like tanks with open top. Will be on the top. There will be a gratings. And some of them are having now checkered plates on top. Now mud gas separator. I'll come to this on the well control system when we go there. Okay, now mud flow return line. I already told when the return mud from the well comes to the BOP, it will go to the mud return line below the drill floor. From mud return line to shell shaker, mud cleaner, descender, and desilter. So and then it will go to the pits down below. This is how the mud return line operates. Standpipe. On the derrick, okay, now derrick, these derricks are a huge structure on top. So we cannot have such a long hoses going here. So what usually we have a standpipe manifold and then the what you call hard piping going up to the monkey board level most of the time because we have got a platform there and we can easily connect and disconnect the hoses. Okay, so this hard piping which goes on the derrick are called standpipe. And the manifold having these two pipes going above are called standpipe manifold. And these pipes are connected to the hoses with a hammer union. So there are different grades for hammer union for 5K, 1502. Then the different grades are there depending on the pressure rating. Derrick is the structure which holds this crown block, top drive, traveling block, and all other drilling equipments. This derrick is always a boltable structure. It's not a welded structure. So if required, we can make this in parts and take it away. So this is how actually it is. And for Aramco, we should have a drop survey done for the derrick structure. And there are certain certified parties only who does this drop survey for Aramco rigs. So they are Aramco approved third parties. And each component which this derrick is having should have a secondary retention. This is one of the criteria for Aramco. So every suppose if we are having a winch, suppose we are having some hoses which are going on top, where this hose is secured to one of the padi with a wire sling as a retention, it will have another padi on the side. So that will be a secondary retention. For bug blowers also, one retention line, there will be another secondary retention. So all these parts should have secondary retention for all the equipments on the derrick. So now drill bits. There are two types of drill bits. One is fixed and one is rotating. So these are the fixed type. The selection of the drill bit depends on the location where the well drilling is required and how is the subsea base. So depending on that, it is chosen. The rotating cutter bits, these are more advantageous than the fixed one because while we are rotating the drill bits, even the teeth here are rotating. So every time when the new area is there, a new teeth will be in contact with the well where we have to drill. So the drilling operation is much faster here with the rotating type. Now these are the drill pipes. The thicker section here are called drill collars. So this is where, for example, these pipes which are stacked here are one end of it is on the drill floor and other end is hang to the fingerboard. So fingerboard will be holding one end on the top. So this is how they stack the drill pipe, and whenever any pipe is required, straight away it is pulled by the winch, brought near here, then lowered down, connected to the top drive, and then the drilling operation starts. So these are the drill collars, drill pipe and drill collars. This is having a standard threading, so which can connect to all the drill pipes. Now slips, these are the ones I was saying. When we go with the master bushing and the Kelly bushing here, So these slips are the one which will hold, which will go inside the rotary here, inside the Kelly bushing, and hold the drill pipe. Actually, these are having like grip. These grips are removable type, all of them. So whenever anyone is wore down, we can replace them. So each and every drilling equipment will be having a thorough inspection. There is some periodic quarterly, half monthly, so they have to go for the visual inspection. Then every 6 months they have to go for total NDT of these areas. So there is some requirement for this drilling equipments. These are the tongs. Tongs we can say like this is same to connect and disconnect the drill bit. Same like how we open the what you call the water bottle. One hand will be holding the cap on top, going in clockwise. The lower end will be going in anti-clockwise. So this is how we disconnect, open the bottle, and closing of the bottle will be opposite direction. So this function is done by the tongs. These tongs are maybe hydraulically operated or manually operated. Now most of the rig comes with hydraulic operated ones. So now we will come to the well control system. For well control, suppose while drilling, when we do the drilling operation, there will be a lot of toxic gases or a lot of things which will be coming out. So the main criteria is the flow inside the well should be such that, which is called as a hydrostatic flow, should be in equilibrium with the formation flow, means external areas of the well where we are drilling. Suppose if the flow in the well is reduced, so this will allow the formation fluid, means external forces, to come inside the well and interfere with the normal operation. Suppose if this formation fluids, external toxic gases and all, comes inside our well where we are drilling, so this toxic gases will be having a back pressure which is called as kick. Suppose if this kick increases, and these are very dangerous things. This can blow out everything, of the full drill floor, full rig can be blown up with this. Suppose if it comes here, then how we prevent it? So once this all toxic gases are coming from the return line up to this area, so what we are having operation from two locations. One, on the cantilever area, there will be one control panel for operating this blowout preventer, and one on the drill floor for the driller's cabin. So when we come to know from the back pressure, there are different things for checking the back pressure on the well. So if there is high back pressure, they will activate the choke and kill lines. So this RAM, these are having a double RAM. So one is operational and secondary is backup. Once, suppose when the back pressure increases, they will close the valve, close the BOP, blowout preventer, one of the RAM, and this will divert this toxic gases to choke and kill manifold. This is the choke and kill manifold. Choke and kill manifold and MGS, mud gas separator. So choke and kill manifold, what she will do is, these are different types of valves. Choke and kill manifold is having. Its main function is to reduce this back pressure, the pressure of the back fluid which is coming, or back gases which is coming. In this, it will go through the series of valves, and then the pressure is reduced. So the toxic gases will go from here to the flare boom. So there will be on the outer hull lines passing, oil, gas, air and water. So these lines will be passing from here. So these toxic gases will be flared on the flare boom. So this is first thing. Then second thing is mud gas separator. What mud gas separator does is, okay, this is the one. Mud gas separator usually has like baffle structure inside. So what it does, it separates the mud and the toxic gases, and these toxic gases will be flared again. So this operation will continue until the back pressure reduces in the well. Once the back pressure, for reducing this back pressure, the fluid pressure coming, mud flow pressure coming in the well should be controlled by the driller tool pusher. So they need to increase this pressure inside so that the hydrostatic pressure will overcome the formation fluid pressure from the outside. So once this comes under control, they can go, they can say, okay, this now we are in a normal operation. They can make out it from their control well system, from the back pressure gauges and all the equipments they'll be having. And then they can continue with the normal operation. So now who operates this valve, this high pressure components? They will be having another unit that is called as a Kumi unit. So Kumi unit will be operating this valves. So for the well control, we'll be having Kumi unit, BOP blowout preventer. This is the heart of the well control system. So this will be operated by Kumi unit. We'll be having in line a choke and kill manifold. We will send the toxic gases and other things to the flaring unit, and flaring of the gases will be done. So this is how the well control system works. Once the well is bored done, then we have to secure this well. So we'll be having cement unit on board. There are different companies which gives this service like Halliburton and all, and they are having cement units on board. So some are 10K, 15K units. So this will be at the end. So this is the Kumi unit I was talking about, which is called as accumulator also. So this will operate the BOP control unit, or the rams and cylinders here. So this is how the flaring is done. This is a land platform. So on the rig, we'll be having like a flare boom, which will be having plenty of lines, oil, gas, airline all passing. And this structure which is holding the flare boom is called a king post. So whenever a flare boom is not in operation, here we'll be having hard pipe, then hard piping going from here, and we'll be having hoses. So whenever this is not in operation, we'll be having some winches here. This will retract the flare boom and hold it in vertical position. So this is what I have for today.
Thank you, Mr. Rajat. Can I ask a question?
Yeah, sure. Yeah.
Our question from the first section of the session. Do all the jackup rig legs move together at the same time, or one another the other, one after the other? Do you hear me?
Rajat, copy.
Do you hear me, Mr. Rajat?
Yeah. Yeah, the thing is, when you suppose, I will tell you one scenario. Once you go the drilling site, once you reach the location, for the soft pin period, what mostly the barge captain will do, he will lower one leg, go for the soft pin. So he will know how much pressure the leg is having. So once that soft pin is done, he will go for the second leg. Then the third leg will be lowered. So when the soft pin is completed, he will go for preloading. So preloading is the very important operation. So once preloading is done, he have to go with all the three legs together. So first operation, he can go single, no problem. Preloading, and after preloading, he have to go with all the three legs.
If during the moving of the all legs together and some problem is happen for one of the legs of the other legs, what do you do?
Okay, you mean to say if there is a problem with the jacking system with one of the leg. So what will be having the barge master will be operating these legs from the control room. on the accommodation top, there will be one control room from where he can see all the 3 legs, and on the jack house top, he'll be having marker there. These markers will highlight him up to which height is the leg. So, and he'll be having those feet marking on the leg for him, so he can see if all the 3 legs are at the same level. He means then the barge is what is in one level. And the second option is he's having an inclinometer there on the bridge or on the control room. Suppose if any of the leg doesn't jacks up, so it will be showing high pressure on the control unit what he's having, the jacking system. So all this jacking system will be having certain pressure rating. These are either hydraulic or electric, means he will be either showing amperage or either power unit or either a hydraulic pressure unit. So if he knows the predefined pressure, how much it will be having, around 300 bar, 350 bar. If this keeps, if this pressure is more, then you know there is some problem somewhere. This is the third criteria he can cross verify. First is from the leg, second is from the inclinometer, and third one is from here. Suppose if that is the case, first thing what he will do is, if rig is not horizontal, you mean to say in level, first he will bring the leg in level. Suppose one leg is down, one level is down, so he will lower down the other 2. He will bring in one level, then he will start working on the jacking system. He will go through the jacking unit, motors, then hydraulic system. He will rectify and then continue the system.
That's okay. Thank you, Mr. Rajat.
Okay, any other questions?
Ahmad?
Yeah, Rajat,
Ahmad?
I'm here.
Yeah, there is one good news. The push-up
finished propeller?
Yeah, push-up finished. Now they will do the alignment of the liner. Then maybe around 10 o'clock stunt tube oil filling and leak test. So I believe by 4 o'clock early morning we should start fitting the rope guard. So sometime 10, 11 in the morning, as we said.
So tell Osama, please. So number 1 as usual, Rajat.
Okay.
Thank you, bye. Thank you. Okay, any other questions, gentlemen and ladies? Okay, Rajat, really seriously, I'm really thankful for your time and appreciate this very good information. It's very valuable one, and of course, sharing knowledge and sharing experience, it is wordless. Yeah. So thank you very much.
Thank you, Mr. Rajat.
Thank you everyone for sparing your time and keeping patience to hearing this stuff. Now it's maybe an hour we are here, and thanks a lot for everyone for sharing your time. Have a nice evening.